Morning everyone. So today let's solve daily LeetCode challenge problem. Doing LeetCode every day will make you improve your problem solving skills. So I request everyone to solve at least one problem a day. So today let's solve this design underground system. So it's basically a low level design problem. So let's see what the question states. There is an underground railway station is keeping track of customer travel times between different stations. They are using this data to calculate the average time it takes to travel from one station to another station. So let's understand what it is saying. There is an underground railway station. There is a one railway station. In that, the customer can check in and in one station 1, and he can check out at station 2. Suppose the customer 1 is traveling in super fast express, then the check-in time and the checkout time will be very less, because s1 minus s2 will be very less. If he is traveling in a passenger, then what it will happen, checkout time will definitely increase. So what we can do is that, what the question is asking is that they want average time it takes to travel from one station to another station. There will be different IDs. There will be different IDs between the different stations, and we need to find out the average time it taken. Like if you travel in super fast or passenger or fast train, anything, we want the average. So let's understand with a small example. So check-in he will give this check-in, and there will be in ID and the station name and how much at what time he will check in. A checkout, if he is traveling super fast express, the checkout time will be very less, and if he is traveling in passenger, the checkout time will be more, the difference. And we want the average time, how much average time it gonna take to travel from one station to another station, whether it's traveling in super fast or passenger or anything. So let's understand this problem with this example. Here decline underground means it will go into this function. First, what is this? This is a constructor for this class. Then underground dot check-in, he will check in, the ID is 45, and he is starting at late on, and this check-in time is 3. It is the first step, it is the first thing. And underground dot check-in 42, this is the first one. And underground check-in at 32, the ID is check-in at Paradise, and time is 8. Now it is also a check-in, it is a third thing, 27, late and 10. Now he is checking out. While checking out, you can see that the ID is 45, here ID is the 45. He is starting at Leighton and he is going till Waterloo, and the checkout time is 15. So if you can see that Leighton to Waterloo, how much time it is taking? 12. Check-in minus checkout minus check-in. And then you can see 27 is starting at Leighton, it is Waterloo, he started at 10, he checked out 20, and 20 minus 10. So by this you can say that in this case he may travel at passenger, in this he can travel at fast train, because the time is less. Let's see the third thing, checkout. He is checking out at, now checkout 32, at Paradise is starting, at Cambridge it is ending. So 22 minus 8, it is 14. And underground dot get average, we need from Paradise to Cambridge. How many people are there? Only the ID 32. So only 14 we will return. You can see here this 14. Now Leighton to Waterloo, they are having this 12 and this 10. There are two paths. So 10 plus 12 by 2, it's 11. Leighton to Waterloo is 11. And what he is saying is checking at 10. New ID which is checking at 10. He is starting at Leighton. The check-in time is 24. Now we want the average time. Leighton to Waterloo, it is same. This test case is repeated over here. Then checkout. At 10 is Waterloo and is checking out at 38. So it's taking more time. 38 minus 24, it's not even a passenger, it's slower than the passenger. We can say for slow passenger. Sorry, I don't have terms to describe that's a slow passenger. Then underground get average. Return to Waterloo. There are how many paths? There are 3 paths. This 12 path and this 10 path and this 14 path. Then we are taking this whole average. Now it is 12. I think you got this example, so I will explain you like what exactly it is saying. What is saying that let's say a customer with a card ID equals check-in at the station, and a customer can only be checked into one place at a time. The only ID can be there. Suppose my ID is 12, your ID is 24. I can come only at one time. Checkout, same thing. If it is check-in, and then only there will be checkout. He will not give checkout unless there is check-in. See here it is mentioned. So get average also will give all the scenarios. There will be a check-in time, checkout time, and there will be start station, end station. So there will be no scenario where you can't find the start station, end station. So there will be no exception cases. Suppose he is going from Mumbai to Delhi, and the input cannot be Hyderabad to Chennai, because Hyderabad to Chennai is not there. So then there will be only definitely Mumbai to Delhi. So let's see how we can solve this problem. If you see this carefully, he's saying that ID can be only one. So what I will do is I will store ID. I want ID, and what I may require, I require string and the time, check-in time. This I can store, right? This I can store in a map. And the checkout time, what I will do, I will according to this ID I will remove it, and this time I will subtract it. Now let's see checkout time. How we need to calculate the average? What we may required, string, what start station, string, end station, and we required all these things. We can store it in vector. All these paths we can store this in a vector. So if you see this, we can use here map, and here you can use map. We can use 2 maps, and we can solve this problem. I have submitted it. I will explain you like what was my approach. You can see here underground, and I am declaring map where I can store check-in time and checkout time, and there is an average. Map of ID, station name and time. This station name and this time we are storing, and we are taking it out. Now he is checking out, right? This t would be greater than this t minus temp.second, and then I am storing this into the average. What is average? This thing, these 2 stations, and I am storing into the vector pushback x. Now if you want the average time, I will remove from this average time, and this is temp, and this is double, and I am adding all the values, and I am dividing temp.size we will get number of elements into 1.0, because we need to convert into double. So by solving this, we will get the answer. By this we can say that here it is taking order of n, and we can reduce it. How we can reduce it? We can use one more function like average. We are pushbacking all these elements. Instead of pushbacking this vector, what I will do, I will use size comma answer. Answer means how many are there and what is the size. So let's optimize this. Let's see this example, this thing. Now you can see that average dot find. So if this start station and end station is not visible, then I am storing it, and I am telling that the size is 1, and the answer would be x, because t minus temp.second. If the start station and end station is present, then we are storing this into the pair, and we are adding into the answer, and we are increasing this size. We are increasing this size, and we are sending this answer. So instead of this computations every time, we are storing this size and this answer, and we are removing it as average pair, and then we are answer dot second divided by answer dot first into 1.0. In this way we will get the answer in order of one time. So we can say that this will take the order of log n, and this will take order of 1, and this will take order of 1. So I think you guys understood the solution, and thank you for watching this tutorial.